Good morning, everybody. Welcome to the panel on predictive risk and data accuracy and AI. I'm going to show the mandatory disclaimer and then say we have an awesome panel today that comes from different walks of life. Because of course using AI for predictive risk is a multidisciplinary problem, like every difficult problem in the world. So we have this amazing panel, folks coming with different job descriptions, different paths, and please read about the panel. They have very, very interesting bios and CVs, and if we were to go through and give them due, we would spend the whole panel on discussing their fascinating careers. So we're going to keep our pictures up, and I am going to kick us off if my phone cooperates. And this is what I get for being paperless. All right, so difficult problem. We all, as security practitioners, have been thinking and aspiring to have proactive predictive risk management for such a long time. AI and Gen AI brings unprecedented promise, but there, of course, are challenges, which is what we're going to talk about. To start, Gen AI is an English major, not a math major, right? So it doesn't do numbers well. It does an amazing job about connecting the dots among different pieces of information, but whether it does so for data, we'll talk about that. And we're going to explore the barriers and prerequisites to this happening today. I'm going to kick us off with a quick example of what I think predictive risk is, and then we're going to ask the panel, because we all, of course, every single person in the room has a different view, probably, of what it is. So to me, predictive risk in security is, could we have predicted, for example, that an obscure piece of accounting software somewhere in Eastern Europe would bring down multiple companies and multiple industries and cause hundreds of millions of dollars of damage? And of course, I'm talking about NotPetya. And all kinds of other well-known and not well-known attacks and breaches. Could we have somehow predicted, could we have had the indicators of this stuff potentially happening and have done something to avoid it or limit its damage? Now, that's my view. I'm going to turn it over to the panel and start with Edna. Edna, to you, what is predictive risk? What is the goal state we're trying to get to?
Yeah, so I'm the goofball that wrote that initial sentence, and it was really my dream. And I think as we were talking before this last week, Hiram pointed something out to me and said he was talking with one of his colleagues who said, I know what the word predictive and what the word risk means, but what the hell is predictive risk? So we thought we'd start by giving you a framework of at least what's in my head. So I'm the former VP and Chief Security Officer for Microsoft's cloud. And I am thinking about, and I also had risk in my remit, so the full title was like a mile long. But when you think about predictive risk, there are three things to remember. One, it's still risk. It's getting a closer degree and fidelity of probability, right? So we've all been using Monte Carlo simulations for a long time, and they work, but we could be better. Second, predictive means it's closer in time to actual proactivity rather than reactivity. So we will know more sooner. And you can use it in a variety of contexts. And for years as an operating executive working on third-party risk and security, I would look at it as I need to understand, Nadia gave you a security application, I'll give you a practical business application. I need to know when I'm going to move certain factors, let's say in a manufacturing plant, based on certain conditions, and I could know better, and I could know sooner, and that reduces the risk to the business. So it's the beginning of the trend that we've seen, and a mantra that I've been talking about since about 2002, which is security folks need to speak the language of business. And we are not outsiders, we are partners. And last but not least, the reason why I have this dream is for years I've been waiting for high performance compute and high capacity storage to come together to enable us to reach this level of prediction, because we couldn't mine effectively the data, as Nadia articulated previously. So that's what I mean when I talk about predictive risk. And on purpose, we pulled together people who I've had the privilege of either knowing or just met who have very different perspectives. So get ready, because we might all disagree with one another, and we wanted to do that on purpose.
Thank you, Edna. So Andrea, over to you. What is predictive risk, and how can AI and Gen AI help?
Yeah, no, thanks. And I will agree with a lot of what you said, so we won't start off being too controversial on that. But it's probabilistic when I look at it. So I do a lot of computational modeling across a whole range of different kinds of risks, cyber one of them, but across supply chains. And when you work on the modeling side of things, when you think about predictive risk, really what you're looking at is closing that time horizon where you can make more proactive decisions. But what we get asked to do is very different than what you can do in reality. And so often when I hear requests for predictive risk, it is more so that, please tell me when, will that financial industry or that financial company get attacked tomorrow? That seems to be what a lot in the more of the C-suite tend to think about when they think about predictive risk, and then they try and pour some resources into getting to that point, and that's when we'll get into some of the data quality and the aspects of that. But there is a bit of a disconnect when we hear predictive risk on the business side and what we actually can do in reality, or what will be the realm of the possible. So I do focus a lot on the probabilistic aspect of it, shortening that time horizon to provide you greater insights in that. But there is, it's interesting, even if you look at like natural disasters and weather and that, where there's really solid data, what they're doing is they're shortening that time horizon, pretty much every decade. And that's kind of when I think about like what we can aspire to, is can we aspire to, as an industry, shortening that time horizon, year over year, we can start having those insights to know which systems might tend to be more vulnerable, but also integrating beyond just the data from the cybersecurity world into more of the geopolitical data and basically the broader socio-technical systems. Because like your example right there with NotPetya, well, you have to take into account the geopolitical context of it, or else you wouldn't have been able to do any kind of prediction within. So you do have to merge all this different data together as well, which is super fun, but also very, very hard.
Awesome, thank you. Hiram, would you like to agree or disagree?
Well, I will maybe just double click on some of the AI elements of this. And when it comes to predictive risk, I would say that LLMs in particular are predictors, but of the next token. So let's call them completers rather than predictors. And I'm blown away by the capability of AI. To double click on what Andrea said, to me, the great opportunity for AI here is not actually in the numerical modeling part, but in the connection to human understanding of textual representations of the context that can now be assimilated into the problem. So there's a great opportunity for me in that realm. But I would just want to throw one example. Maybe some of you saw this, but if you were to ask ChatGPT 3.5 Turbo to choose a number between 1 and 100, and you did this 1,000 times and created a histogram, you would see not what you would want in a uniform distribution, but guess what? There's a peak at the number 42, right? And this shows you this is not a tool for Monte Carlo numeric simulation. This is a tool to regress to shared human experience, that the number 42 appeared, apparently, more often on the internet than the other numbers, and so it's more likely to predict that number. It's probably not something you'd want to boil into your numeric prediction. But the human understanding side is extremely powerful.
Wow, what a fascinating example. I did not know that number 42 appears on the internet more than other numbers.
It's because it's my age.
So obviously we're very, very excited about the possibilities, right? This is a point in time where all kinds of things created a confluence of dreams and aspirations. Business leaders are asking, what should we do with this? The technical people are trying to comport to that. Something we haven't, so a bunch of things have changed over the last 18 months. Something we haven't talked about yet, and I'd like to hear your opinion, is that there are now actually standards and guidelines that kind of talk about this stuff. What do we think of those? Are they helpful? Are they not helpful? What should the audience know about them, and how should the audience apply them, if they should apply them?
So I can kick off real quick, and then Edna's got a lot of thoughts on this too. So I think it's a good movement. I think that it's always going to be, as these first initial ones come out, there are going to be a lot of lessons to learn coming from it. But what I think the benefit is that's starting to give us a common framework and common language across the different industries. So we have that baseline and common understanding to be able to then think about what needs to be done. And the good example, the EU has an AI Act, NIST has an AI framework, all the way to OWASP has their own checklist for doing AI security. And so these are they're coming out from the policy side, from more of the tech community itself, and they're also starting to actually kind of converge on a common definition as well. And what I personally find very interesting is that the definition of AI in these regulations, the EU AI Act basically borrowed a lot of it from the OECD's version of it. And my almost synopsis of how they define AI really is almost an the computer doing automated processes that humans normally would do. So it's a whole lot bigger than in how I was trained and how I grew up thinking about what AI actually is. And whether I agree or disagree with those definitions, it gives us all that baseline that this is what we're talking about when we're talking about AI. And then you get into the different components of it that get into how to address bias, how to provide transparency. They basically break apart data by kinds of risk, and they contextualize it like what Hiram was talking about, that using AI automated systems for something like nuclear weapons may not be the way to go, but if it's doing it to produce a recipe, probably not that big of a risk, depending. And so they also are starting to create these different components and tier system of the data and the context as well, which I think is really helpful. I think there's going to be a way to go. The US still has a way to go. We have an executive order, and we'll see what happens from that. But I think it's a good movement. And I know I've heard a lot on the pessimistic side that it's too late, it's already out there. But I feel like we can't think about it that way, because that's giving up. Like we want to help shape where this goes going forward.
I think that it's important to not lose sight of the purpose of standards. The purpose is not to be the first standard or just to have one, but it's to solve a problem. And I think that many of the standards we already have are useful vehicles to channel our energy. So piggybacking off the things we already know in cybersecurity can be useful for what's happening in AI. That said, there's a net new here. And the net new, I'm pleased by the energy that's coming, but we need to be thoughtful about that. Not just to be, sometimes we have a tendency to have competing standards, right? And the good part about that, it's a sign that there's energy, that the right thing is happening. But the outcome is not to be first or the winner, it's to have the right thing happen.
That's a great comment. I know as a moderator I'm not supposed to comment, but I can't resist as a standards person. I love you saying that we don't need new standards when we don't need them. We have so much good content already out there, already used, already known, that we can just apply to this problem versus creating something brand new. I think that's awesome. And we see a lot of commonalities, and I see a lot of commonalities in my work between how we take specific security standards, security guidelines, and apply them then to AI, Gen AI versus some other things. But there's, of course, net new there that we need to do something about. And I know Edna wants to say something, so I'm going to pause and turn to Edna.
No, I think that what you said is intriguing. I mean, it's a separate theme from this, but I think for the first time what we've seen is, look, I do a lot of public-private partnership work, and I think particularly, I'm going to be biased, but let me be biased for a moment, particularly in the US, where you see the differences between the European AI law, which is, very deterministic and thou shalt do this, and the jury's still out on what we're going to have in the US, but you can see an embracing of the private sector and a whole host of comprehensive ramifications. So I think that's going to lead to something that's a little different than, Nadia, you and I had the privilege of testifying. I remember before a government agency years ago, and our theme was, there's already enough out there, please don't create something new. I won't say which agency it was, and sure as shooting, something new was created. And I think that I'm seeing a change in that. There's an alignment and a comprehensiveness and a shared mission that's pretty exciting. Now let me answer the actual question. You said something really important, which is that broad, this is why you bring deep technical experts as well in fields, because the way you would define ML in particular is different than the way I want to use it to some degree, because you're looking at actually deploying it in a certain way and how you generate it. But we all agreed on, and we've all talked about this in both data science. This is an area where data science and security converge, right? So garbage in equals garbage out. How do we address that? It's all about the data. I think for the first time I'm seeing accuracy being demanded in standards. And so far, all of the brouhaha that we have seen around AI, people are talking about bias, people are talking about, and we'll talk a little bit more about what you can do to address some of that, but nobody's talking about accuracy of the data. And so I think figuring out what data you need and figuring out that it's the right data, and then more importantly, vetting its accuracy before ingestion into the ML system, or at least refining it as it's utilized in the ML, is something that's really important. But here's 3 exciting things that I wanted to talk about from standards. This is, what I do when I'm not sleeping. So I looked for any evidence that I could find that we were starting to think about accuracy of the data. So the first one is the NIST. If you looked at the risk management framework for AI, it's the first one out. It's 1.0. And 1.0 has the following language, which I wanted to read you because it made my heart sing. Accuracy and robustness contribute to the validity and trustworthiness of AI. It goes on. But accuracy is the first word. And they then went on to reference, as ISO so often is, another standard that defined accuracy. Closeness of results of observations, computations, or estimates of true value. Now just think about this word, this set of words. Estimates to the true value. If it's a true value, you can't have an estimate. But it recognizes the beauty of what I'm calling predictive risk, because we can utilize this to get closer. So that's NIST. Second one, you already mentioned OWASP top 10, I think, Andrea, right? So I'm pretty excited about, RAG, and I think if you look at it, what you get really is something that's pretty exciting, because I have this dream that Hiram's teaching me. I can use different words, but I can get there. I wanted to call it enclaves of separate information or applications. And so I've learned I now need to say I have a separate, unique application of the AI, right, with a specific model, with a specific goal in mind, and refine the accuracy and refine what data is ingested at the outset, and select for that particular application. And that's exactly what large language model optimization is. And so OWASP actually encourages the use of RAG for that purpose. And then the last thing that I thought was really fun was ISO 42001. So, we have a standard on AI. ISO standards by their nature are often very general, but there is an annex. So at the end of this, you're going to understand how truly weird some of us are, because nobody reads the annexes, but they're important. The Annex B had a control that, again, made my eyes light up. And what it said was this: the organization should define, document, and implement data management processes. And it goes on. But here's what they put in the implementation guidance. Transparency and explainability aspects, including data provenance and representations of training data compared to operational domain use around accuracy and integrity of the data. So now you're starting to see the standards. Think about how can we use this? You're hearing people say, I'm doing it on some mundane, repetitive processes that will enable the humans to do better, right? Let's use humans where we can. And I always tell everybody this: if they had asked me, which clearly they didn't, we wouldn't call it artificial intelligence, we would call it enhanced intelligence. Artificial intelligence is not smarter than you. It just does some processing faster than you do. So all of us are still going to remain humans. I do think, however, that this is a fundamental area where we're seeing standards, we're seeing government, we're seeing the private sector and academia come together to say, how do we effectively use it? Yes, bias is an issue, but let's get the data correct first. And the dream that I think I'm going to have to spend more time talking to Hiram about is, I don't think we can fix it all algorithmically. I think some of it has to be in the policies that we set on how we use it. And I'll give you 2 examples. I'm sorry, I'm going on, but I need to share this one. So I'm going to give you a manufacturing example. These guys have heard this and they're sick of hearing it, but I have a manufacturing plant in a particular part of the world. It suffers from a type of weather. That weather incident is happening. I need to know, is my manufacturing capability at risk? Okay, I use some data that is real and ingested from a highly trusted and vetted area. I use other data that I get from the plant manager that comes from their measurement of certain aspects of that data. Let's say it's rain. That is a tin can in the backyard that got knocked over twice by the dog and isn't factoring in any kind of evaporation. It all goes into the model. The model says, yeah, at this point in time, you need to start thinking about moving some manufacturing capability to another part of the world. Can I do that algorithmically? Maybe not. Some can be algorithmic, right? You talked about data around weather as being one of the high fidelity areas, but it depends on where you're getting it from.
Sure does.
Right? So I think this is what I have hope for. The standards are starting to recognize it, and we will get there together. And part of the reason why I'm very excited, I thought 5 people would come to this, by the way, so God bless all of you who came, because we're way ahead of the curve. We haven't gotten there yet, and we have the chance to actually start to write the policies that are going to make sure some of the basic foundations happen at the outset and always happen and are built into the standards and the laws.
And then we're also at the same time at the point where the technology can actually also help move us towards that vision, right? So that's also the super exciting aspect of it, is that we are moving, we are shortening that time horizon, and we're actually are talking about the data now and not 5-10 years from now, which I'd say for us as a society, that's a big improvement compared to where we have been with technology over the last 20 years or so. So I think that growing discussion, because there isn't much discussion, but there is growing discussion on that role of data. And like you're talking about with the weather, what happens with the site that you depend on your forecast all of a sudden drops offline, or they decide to change how they're measuring certain things. And this happens all the time. So it's, when we think about the automated component of it, even if you're pulling from the same source of the data, when they start to adjust how they're measuring certain things, you have to be aware of that. And so that's, it's one of those things, it's got to be cyclical and discontinuous, that data quality assessment. And that's why I think, Hiram and I were talking earlier about AI bombs, and it almost seems like that's a good segue to talk about that as well, because it's a combination of what's going on the tech side and where some policy is going, and also not reinventing the wheel, but almost adjusting to take into account the AI component. So
we're getting very meta and changing from predictive risk to actually the risk in the models themselves through the data that are used to predict it. And just like to take this to an extreme, a year and a half ago, colleagues and I published work about practical data poisoning. And all the cybersecurity people will get this. All that we did is we looked at what data sets were being used to train the largest LLM models. And they're so big, these are no longer things you can download onto a thumb drive. You actually scrape them real time from the web. So what do? We waited till the domain expired and we bought them. In fact, we bought enough to poison, it only requires about 1 in 10,000 training points to poison a model. And we did that for $60 US, bought enough domains to affect that change. So our ability to control for that is very simple, but people aren't abiding to these standards just yet and whole. So that's something that's super easy to do. People are getting in place, but it is sort of a necessary thing. That's the extreme example of when you're trying to nefariously do it. I think quality is a concern that's maybe even a harder problem, right?
Yeah, so say more about risks, and I want to continue pulling this thread with you, Hiram. What are the risks, right? We talked about this amazing promise. We talked about what concerns we have, what's working, what's not working, but what are the real risks of us not getting this right?
Yeah, so this relates to this concept of a software bill of materials for AI, an AI bomb that's being talked about, that allows us to measure and track the provenance of data, of software that go into a model that have all the outcomes on how that model behaves, including its bias, including its accuracy, including susceptibility to an attack. And the risks are all along this supply chain. And they're multiple steps back, right? From where did the data come? Often in this process, there's a foundation model that then gets fine-tuned, and then one builds, as Anna said, a RAG application that brings in more data, usually from the web. And all of these are different sort of vectors for this application to have corrupted data flow in it. So mostly it comes down to data, software, and models that are taken from third parties that one needs to control, to understand, to measure, and reduce the risk in that.
How can we work on this more? Like, how do we solve these risks of data accuracy? You talked about one. Are there other ways? The standard for SBOM will certainly help. But what else can we do as a community to move forward with the promise while responsibly addressing the risks of bad things resulting from our cavalier use of technology?
So I'm going to define risk as probability times severity. And one thing we can do is we can control the probability by reducing the likelihood of bad data coming in through regular checks. I think Andrew mentioned this. The tools are immature, but they do exist for you to vet the data. There is no replacement for human sampling and inspection. That should be a part of that. The second thing is to reduce the severity of those outcomes. And that often happens by us designing these applications in a way that don't violate basic trust boundaries. In a worst case scenario, do I really want to be using predictive risks in a nuclear scenario? No, that would violate my trust boundary. So that's how we reduce risk. I think it's, in my view, can be simplified.
And I'll just
Please.
maybe double tap on what you said about the human in the loop, because that is something that gets lost as well. All these big systems that you hear about that are currently revolutionizing so many different things, there were humans involved, and there was humans were doing sampling as part of the development process. And so even when you think that there's not, and sort of the marketing basically says it's 100% automated, on the data side, and even on the algorithms themselves, humans were there testing and sampling in the majority of these cases, and if they weren't, then that's, to me, that's where you start. Those are the kind of questions you want to be asking when you're looking at different kinds of vendors along those lines. But humans were in the loop, and I think it's an important part, especially when you think about the whole range of domain expertise that is necessary to ensure the right data is going in. There was a time, I think, for a good part of 2010 to 2020 where the thought was you just throw enough data into it and you're going to get some interesting and useful output. And there finally is the recognition that it's not going to necessarily be what you want it to be, and that's where the whole the hallucinations that we hear about a lot, that just throwing enough data at it doesn't give you the solution that you want. It has to be the right quality of data, and you do need humans, and humans with specific domain expertise, depending on the context, to be reviewing that data. And even once you have all the data, how you even integrate all that data is a huge challenge. There are so many different data types that are out there, and bringing all those different data types together is an extraordinarily large challenge and super prone to different kinds of errors going on. You just even think about entity resolution issue with people's names or company names is a very big challenge because they're all spelled differently and there are typos and mistakes are made. And so there's a lot of data quality components that really should become one of the core aspects of what you're looking at and what the features are. And so I'd say ensuring that is part of it to me is one of the biggest ways to help control the risk of the models themselves and of the data itself. But I think there's also the social aspect of just pure blind faith that goes along with it. And I'm going to tell the podcast story. That so we did a podcast previous on this, and it was like 20-minute conversation. And when they went through and did the summarization of it and put it online, what was put online was about a 3-minute. And half of it was a commercial. And it's because the AI system that they were using was just trusted blindly to take the recording and put it online and have it all work out wonderfully. And there were no humans that actually checked to make sure the actual correct recording and the correct formatting of it all was actually placed online. And so that's not a big deal. That happens. But in other scenarios that are much more serious, blind faith in the AI output poses a serious risk. So I think there's a whole lot of education that also has to go along with it.
So that leads to what, you asked, what can we do? I think we can have, and that's a great example. It took these two humans nagging to say, and I also, in addition to being an advertisement, the next podcast was right over my face, which I took personally. I do think you have to have a policy, and you saw a knee-jerk reaction across industry. AI, wait, stop. The first policy said, do not put any of our IP into any large language model. We don't want it released. A few of them started to think about top P level and temperature controls. Most of them didn't. What if we began to write a policy that said, when utilizing these kinds of models, here are the things that you need to do across the spectrum of your use. So the supply chain, how do you select which one? How do you vet the accuracy of the data going in? And for anybody who does coding, if you remember, I remember when coding first started, I'm the vintage of you came out of the building that had the computers in it, and you had cards with holes in them. It was magic.
42 years ago.
That's correct. It was a magic system. And then we said, well, the code is always right. Well, then we said, nah, you probably have to apply, SAST and DAST. And we have this model, is I think where Andrea's going. We've used it in other scenarios. We can use it with this new technology. Sometimes we have to, and we in particular as security professionals need to step back and say, stop. There's a process here. We can do it in our policy, follow a process. Here's where I want you to go at the outset of selection. Here's how many times I want you to vet the data. And I want humans. And oh, by the way, that data is going to be used by somebody in manufacturing differently than it's going to be used by somebody in procurement, differently than it's going to be used by somebody who's spinning up that new business unit who says, oh, I have a great way to do some analysis that will get me to the magic marketing words that will bring in business faster. Everybody looks at it in a different way. That's the potential. I mean, we're sitting here at RSA, right? The art of possible. That possible is so exciting. We're blessed to be around at this time. But we need to write the policy to say, set the stages, articulate what testing you're going to do, and when it comes out, look at it. Actually review it. She just gave you the glaring example. Does it make sense? How many of you have sent an email that you dictated and forgot to review before you sent it? I have. I've gotten some interesting feedback on those emails from people. And so I think we just need to build a policy that says, here's how we use this new technology. We apply some things like the old school thinking about network segmentation, which has my enclave per application model. There's direct analogies, and we should be at the cutting edge with our development and our data teams to say, here's where you inject, here's where you inject, here's where you inject. And we will get better fidelity for it, and it will give us, as security professionals, a whole heck of a lot less work on the back end.
So Edna, thank you for starting. This is awesome, and I got the Q&A signal, which we will do Q&A in a moment. But before that, we have to give our audience practical advice for what they can do on Monday when they go back to their daily jobs. And you started us on that journey, but I want to throw a little bit on top of that. So I'm sure some folks in the audience have experienced the call from upper management that said, use it, you have to use it, do it somehow, and they're wondering, like, what can I do, how do I do this, which is inherently risky. So in light of this, how corporations want to use AI and Gen AI, and what can we tell our audience to do differently when they leave the conference?
That.
Okay. Anything else? That's on the slide, folks, and you'll have access to that. But Andrea, what do you think?
I think almost even an initial step is just finding out if you have an AI policy in your organization. And I think many don't. And I've seen in many cases, especially small organizations, don't necessarily. And so if you don't, that's probably a good idea to look at that and then leverage the existing frameworks. And if you need some sort of impetus for it, say the regulations are coming if they don't want to do, if they have no other reason to do so in their mind. And so that's usually a good push factor to make focus on that. And then look across the, like Chaim was saying, the supply chain. What data are you using? Or if you have vendors that are providing AI to you, where are they getting the data from? How are they securing the data in the models? And then look at how you're actually using the output of that and making sure that does it fit the context or is an interpretation correctly? Because in many cases you'll find out with some of these, that these models are different programs that are out there, two different people might interpret the output in different ways. And so those are good conversations to have then. And that's where, again, we're getting closer to learning and narrowing that time horizon on it. But using it to help spark some of those conversations also could help expedite a lot of the strategy and processes and so forth. So I look in a bunch of different ways, but also look at the different tiers of risk and how you're actually using it. And if they're in areas that are really high impact, focus on those first.
Highly want to go next, and
Yeah.
you can wrap us up.
For
Yes,
sure.
yes,
Let me
yes,
first say, just honored to join a panel with all three of you and talk about this subject. My view is that whether you're using AI for predictive risk or a consumer application or just to tinker around yourself, you should personally and in your organization have a risk management framework that you can snap on the AI elements and those novel elements. And that's table stakes to getting started. That might include doing things that we're used to doing in cybersecurity, like a risk assessment of the model you plan to use in your application. That will go a long way for your company culture and your process to begin to use this, strap yourself to this race car, which is exciting. And I hope you all do. Like I'm very pro AI, we're gonna go far, but you can do it best when you have the culture, kind of the practice in place to do that. I'm happy to talk to any one of you after this session about where you might get started.
Fantastic.
Amazing.
I always wanted a Ferrari. Look, I think what we have up there is table stakes if you're just starting. I think having the policy, making sure you have a seat at the table. Whoever's talking about it, you need to be there. So we still talk a lot about our CISOs at the table. If you're not a CISO, you still need to be at the table because you're the one doing it. And last but not least, I think, remind people of both the frameworks we just talked about, so 42001, Annex B, read the annex, also OWASP Top 10 and the NIST framework. And last but not least, if you're a small company, leverage your investors or your advisors. If you're a larger company, go talk to your board because they will buy in. I sit on 4 boards and I am asking folks, what does our policy include? What is our process? Where are we embedding testing and validation in every stage of both selection, utilization, and ultimate deployment of output that has been generated via AI involvement?
Thank you. What an awesome wrap up. We'd like to open it up for Q&A. There are 2 microphones in the room. And I don't believe there are no questions. There have to be questions. There was so much shared. So please, anybody would like to ask a question? Thank you so much. Thank you for getting us started.
Hi, I work at the UK standards body, so I really enjoyed the nerding out on annexes. But the question I wanted to ask is about the kind of step before we think about data quality. A lot of interesting data is held privately in organizations, and thinking about cyber data in particular, there's often fear about sharing it even within an organization, let alone between organizations where it could be mutually beneficial. Have you seen any change in that mood since the kind of explosion of AI interest, and what kind of tools can help encourage that? Yeah.
But my cynical response is that companies who are using those to train models and releasing those models are actually sharing the data. You know, to somebody who's motivated, you can get hints and teases out. But I'll let others comment.
Look, I sit on a couple of task forces sponsored by the U.S. government and also work with NATO, which includes you all. And so I think there are increasing commitments to information sharing. Hard to do in democratic nations because of the risk of liability and lawsuits. And so that kind of public-private sharing model, which gives you a bit of a safe harbor, not perfect safe harbors, is something that we're seeing more and more of, and security has led the way on that information sharing, and we do need more of it. There's just a challenge between parsing what's useful to the community and what you think is your differentiator from an intellectual property perspective.
So I think it's also useful for expectation management when people are talking about predictive risk, because there is, like, to exactly your point, there's a lot of data that is required for certain kinds of predictive risk that is proprietary and that they're not going to share. And I think that's where it gets into some expectation management on what areas we can predict, given, I'm a little more cynical as well, the human nature to, against sharing. I think we're seeing some good advances on it. We saw it in cyber, some good examples of groups that are sharing well, and when you think of, like, across your entire supply chain, we're starting to see a bit more information being shared across supply chains, but I think it's going to take a little while. And so I do think that, while we've got, like, a data deluge out there for, the realm of what we can do with that, for very specific cases, though, there's a data desert. Like, the right data just isn't there because it's just not broadly shared. And so I think depending on how things evolve, at the end of the day, it's going to require incentives. If it becomes in the company's incentive to actually share, they'll start doing it. If it remains not as highly prioritized, then there's not going to. So the incentives just have to be there for it to happen. But the good news is with sharing, it snowballs, right? It's not linear. And so the more and more groups that come together and can trust each other and create those ecosystems, I think you'll start seeing, an exponential increase. So I think that's not going to be a linear outcome, which gives you hope. So I'll do the hope and the
Yeah, and trust is really important, because some of the data is legitimately proprietary or risky to share, but some of this is about shame, right? Something happened to us, and it must be we're bad, and we can't share because we're ashamed of sharing. And we've got to stop that. We've got to move beyond shame, which is why I think these trusted circles and public-private partnerships that establish the trust, the sharing is emotionally better because, well, there's no longer shame associated with sharing.
It can
We've got
also
to
be
get beyond that.
anonymized, to your point, to form.
Exactly.
So if there's no more questions, we have another.
We have a question. Thank you.
Let you go first, because I have a pitch to ask for all of you.
Okay.
Who stayed.
So really quickly, staying along the same lines on data challenges. So when you talk about bringing all of this data from different places, there's significant challenges around being able to integrate that. So you have impact data, you have, data that's measuring different things. Sometimes the way things are coded, the dates, et cetera, don't match up. So how do you look at a little bit of that data integration and that part of it in order to be able to create a model that has your X and your Y, your target data, and helps in the predicting side? And then if there's a little bit of time, just how, when you're talking about predictive risk, how do you account for those, black swan phenomena kind of thing that are so common, especially nowadays? Thanks.
Hiram.
I defer to you, Nadia.
I'm just the moderator.
That's a great question. I don't think we have all the answers, except data will never be perfect. It's the nature of data, because it is produced by us and we're imperfect, and computer systems are imperfect. So, for a long time, I worked just as a data scientist, actually, with Andrea.
We're just a data scientist.
Exactly. And the hardest problem about modeling is getting the data right. And I don't yet know an answer besides hard work, inspection, and I apologize. The black swan is a question I am totally not capable to answer, and I will defer that to others.
So I'm interested in the data diversification, right? So that is a huge challenge, but that's where I think domain knowledge of the data set itself is absolutely critical. Because I've worked at places where people just kind of try and throw all the different data together, and what turns out, even like dates turns out to be something that no two data sets seem to do it the same way. And it's the same thing with names and locations and all those kind of things that are really critical foundationally to the data. It requires domain knowledge of the data set. We've done experiments where leveraging machine learning to solve some of these versus some of the domain knowledge. And guess what? It's a combination of the two together that actually can give you the best outcome. And so I think learning how to best leverage the machine and human knowledge together helps address that. But it's a problem that I think gets overlooked a lot and is way harder than people give it credit for. Because even when you think about like financial data, like, oh, that's just easily, it's very well structured data. Financial data is a mess to deal with. So even like the most structured data that seems to be very prone to and lending itself for predictive risk still has its challenges. And so we're still at the point where data scientists spend a significant amount of time munging the data. That's why Rom's got the name Data Cowboy, because he's got to wrangle the data. So that's, I think until there's some data standards on the structure, which I don't think we're going to get to anything along those lines, it's going to be a challenge. But it keeps us all occupied, so that's a great point.
Let me offer one suggestion. I have one board that is doing this. We've actually created a council, and we force every organization to have a representative, and they have to be at a certain level, so that when we're looking at potential data ingestion, we're looking at it from the perspective of each and every one of those organizations. And you'd be amazed the debates before you even get to using and applying the model, where somebody from one group will say, no, that's an invalid assumption, let me tell you why in my space.
Something's
Your
happening
mic.
with the mic.
But it's okay, I can use the Brooklyn voice too. I do think that, again, the people are not going away, so it's up to us to effectively utilize not only on both ends of the pipe, but in the middle as well.
So I'm hearing standards, policies, cross-organizational collaboration, and driving from the top, and involve the humans. Don't trust the tech, which is not a new theme, right? Involve the humans, make sure that humans have a say in what goes in and what comes out, inspect what comes out, validate what comes out, and then it might actually work
That's a great summary.
eventually.
You have a question?
One more question, I think. we're
Yeah,
out of
first I
time for one
wanted to thank you. That was really good. Really enjoyed it. The only thing I wanted to react to is you used the word shame, and with respect to cyber and disclosure on cyber things. And as we were talking, yes, if you do put your cyber info into an AI model, you probably have already disclosed it. But a lot of people are more concerned about inequitable disclosure and liability associated with that, which is why they don't necessarily want to share it into some of these models and some of this stuff, because at the point that it gets scrubbed, you go from there's a vulnerability in ABC, which can be do such and such, to injection attack. So it's not so much about shame, it's about not being able to communicate it. So just keep that in mind as you're thinking about it. We're not shaming, we're trying to not get sued, which is
Thank
as
you for your
bad as being
comment.
shamed.
Edna, you have 1 minute for your pitch, unless we have more questions.
So if anybody's interested in participating in a study group that I'm going to spin up under the umbrella of a particular U.S. agency to think about AI data accuracy, please find me. I'm easy to find on LinkedIn, and I'm even easier by email. It's because I've never been in marketing. Edna@ednaconway.com. Thank you. Thank you for sticking with us. We appreciate you being here.
Thank you very much.